In this session, we're going to solve tutorial sheet 5, Trigonometry 2025. So without wasting much of the time, let's start. Now, this is the first question. We are instructed to copy and complete the table of functional values. Okay, and there we have our trigonometric ratios, sine, cosine, tan, cosec, and we've been given values here, negative, 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 like that. Okay, so to explain this further, I'm going to use a table. Allow me to use a table. Let me come up with a table of values. Okay, so let's call this one okay, so allow me to raise the last part. Okay, it's fine like this. So this is cosine, tan. Let's put another one. We can put cosec, we can put sec. Let's also put cot at the end. Okay, so now let's put the values here. So let's start from 0 degrees. Okay, then we're going to go at 30 degrees, we're going to go at 45 degrees, we're going to go at 60 degrees, we're going to go at 90 degrees, 180 degrees, 270. Okay, we can even end at 270. It's fine. So now we're supposed to find the trigonometric ratios. Okay, in terms of we have to solve these angles without using a calculator. Okay, so now before I start solving this diagram, I must make mention something. When we are learning about trigonometry, we talked about something, an isosceles triangle. Two sides are equal. If this is my isosceles triangle, let's assume this side and this side are equal. Therefore, these two angles opposite, they're also going to be equal. And let's call this one as a 90 degrees. So 90 degrees, and the triangle adds up to 180. So this will be 45, and the other one also be 45. Okay, because these two sides are equal, allow me to give them this one as a unit of 1 and the other one as a unit of 1. Then when you solve according to your Pythagoras, this is going to be the square root of 2. Okay, then how are you going to find sine of 45? How are you going to find the cos of 45? How are you going to find the tan of 45? Okay, then we also talked about another triangle called an equilateral triangle. Okay, so allow me to draw just the half part of it. Let's say this is our half part of it. Okay, and let's say this is 60 degrees, that is 30 degrees, and you have a 90 degrees, like that. This has a unit of 2, this is a unit of 1, and this is a unit of square root of 3. Now that we've got this, we're also supposed to find sine 30, sine 30, cos 30, all those kind of things. Okay, sine 30, cos 30, tan 30. Then we're also supposed to find cos 30, cos, let's say sine 60, sine 60, cos 60, and let's say tan 60. Okay, so let's start with the first diagram, this one. So what are we supposed to know? Sine 45, according to your famous soccer tour, your sine is opposite over adjacent. Okay, so opposite to this angle, it is just a 1, okay, over your hypotenuse. So we are going to have 1 over root 2, okay, opposite over hypotenuse. Then your cosine or cos 45 will be your adjacent over hypotenuse. Adjacent to 45 is 1 over root 2 as well. Then cos 45, then tan 45, tan is equals to opposite to this angle is a 1 divided by the adjacent, which is also 1. So therefore just going to have 1 divided by 1, which is just a 1. So this is how you find these ones using special angles. Okay, now we've got sine 30 on the other side. How we're going to find sine 30 is the same thing, opposite over hypotenuse. This is our 30. Opposite to 30, you are able to see that it's a 1, so it will be 1 over the hypotenuse, which is 2. Okay, 1 over 2. Then the cos 30 would also be, cos 30, it is adjacent over hypotenuse. Okay, so that would be root 3 over 2. Okay, then we've got our tan 30. Our tan 30, what is it going to be? Opposite to sine 30 is just the 1 over adjacent. Adjacent to 30 is just the root of 3. Okay, so we're going to have 1 over the root of 3. Okay, then we've got sine 60, and that's how you're going to solve all these ones. Now you're supposed to know these ones by heart. Okay, so that is very important, and based on this information, this tutorial sheet, that's how we're going to be solving it, from this basic. Okay, so that is very, very important to know. Then another concept that you're supposed to understand, I'll not solve the other ones because it's just the same concept. Another concept that you're supposed to know is how you know that angles can either be measured in degrees or in radians. So you also have to know the conversion factor of angles. Okay, so if you are finding an angle 360 degrees, it's just equals to 2 pi r. Now if I divide by 2 on both sides, I'm going to have 180 degrees is equals to pi radians or pi r. Now this is a general equation that we'll be using to convert angles to radians, and these are some of the values that they've given you. Okay, so now let's complete the table that I just came up with on the other end. Now if you punch on your calculator sine 0, it is just a 0. Okay, sine 0 is sine 0. Then sine 30, we've said sine 30 is just 1 over 2. Sine 45, it is root 2 over 2. Sine 60 will be root 3 over 2. Sine 90 is just a 1. Sine 180 is a 0. Sine 270, it's a negative 1. And they repeat when you put your 360. Now we come to cos. Cos 0 is 1. Okay, tan 0 in this case is a 0. Okay, now cosec is the opposite. Cosec is the opposite of sine. Okay, so now if you are going to be dividing by 0, that will become undefined, right? So because it's the opposite, so this will be undefined. Allow me to write un to represent undefined. Then sec will be the opposite of cos, which will just be the opposite of 1, will just be a 1. Cot will be the opposite of tan. The opposite of 0, again, when you flip that, or when you flip that, it become undefined as well. Okay, let's come to 30. Cos 30, we've just said it is the square root of 3 over a 2. Then tan 30 is the square root of 3 over 3. Then cosec, since cosec is the opposite of sine, the opposite of 1 over 2 is just a 2. Then since sec is the opposite of cos, so the opposite of that, it will be the opposite of root 3 over 2, it will be 2 over root 3. Okay, so these ones will just be the opposite. Now I'll just be putting sine, cos, and tan, and everything that will be on the other side just be the opposite. Okay, now cos 45 is just root 2 over 2. Okay, from our special angles. Then tan 45, it is just a 1, like we found out. Then cos 60 will give you 1 over 2. Tan 60 will give you a root 3. Then when you come to 90, okay, tan 90 or cos 90 degrees, it's going to give you a 0. Then tan 90 degrees will be undefined. I'll write it as un. Okay, then come to 180. Cos 180, it is a negative 1. Tan 180, it is a 0. Okay, then 270, cos 270 is just a 0. You know, tan 270 is undefined. Okay, so now here where they are undefined on the tan, it's based on the graph. When you look at the graphs of these functions, which I'm not going to draw, but you're going to see as other questions unfold where I'll be solving graphs. So it's undefined because for tan on 90 and 270, that's where you find your asymptote, where your graph is not supposed to touch a certain or a particular point. So on 90 and 270, it is undefined because you're not supposed to touch that line. Okay, so this is just the introductory. Let's now solve question number 2 based on the foundation that we've laid. In the following, one of sine x, cos x, and tan x is given. Find the other two if x lies in the specified interval. Okay, so A, we are given sine x is equals to 3 over 5, and we've been given a range. X is a member of pi over 2 pi. Now I must mention something. If you are going to be converting, you know, these values to radians, like that is a conversion factor. Like for 0 to just be 0. But if we're converting 30, if I'm converting 30, we've said the conversion factor is, if I'm converting 30 degrees to pi radians, I'm going to do pi over 180. Okay, that will divide. So 3 into 3 is 1, 3 into 18, that is like 6. Okay, so this is just the same as pi over 6. Then for 45, you're going to do the same. You're going to get pi over 4. For 60, you're going to do the same. That will be pi over 3. Then for 90, pi is just 180, right? So that will just be divided by 2. Okay, then for 180, we're saying it's just the same as pi according to our conversion factor. Then for 270, it will just be 3 pi over 2. Okay, so that is very, very important for you to know. Now we've been given a range here from pi over 2 to pi. Now pi over 2, we've said is 90, so it's from 90 to 180. Okay, so how are we going to solve the first one? Okay, now you're able to see that from 90 to 180, this is the second quadrant. Okay, now I've brought the issues of quadrant, or the basics of quadrants. So we usually denote this as all students take coffee. Okay, or in this case, all the trigonometric ratios are positive. Here only sine is positive, here only tan is positive, here only cos is positive. Okay, so this is the thing. So this is allow me to call this one as 0, 360. This will be at 90, this will be at 180, this will be at 270. Okay, now we have an angle between 90 and 180. Okay, so probably it's somewhere here, and in here sine is positive. Okay, so that is very important for you to know. Now we learned about something very important here, trigonometric identities. Okay, you know that your sine squared of x plus your cos squared of x is just equals to 1. But we've been given what sine x is, so we can find cos, because the question is in the following, one of sine x and is given, one of them is given, find the other two if x lies in that region. Okay, so we're just going to do that. Okay, so when we solve this, sine x, we've said it is 3 over 5. Now this is squared, so I'm going to put a square. So I'm going to put a square plus cos squared x is equals to 1. Okay, now you know that this the power drops on both of them, so 3 squared, that is just 9, 5 squared, that is just a 25. Okay, plus cos squared x is equals to a 1. Okay, now if I take the 9 over 5 to the other, 9 over 25 to the other side, allow me to rub this part. I'm going to have cos squared of x is equals to 1 minus 9 over 25. And when we solve, we simplify this one to a single fraction. That will just be 25 minus, that will be 9. Okay, so that would be like 9. Then 25 minus 9, what is it? Okay, so of course squared x is equals to 25 minus 9, that is like 16 over 25. Okay, okay, is it okay? Yeah, we've done the right thing. Now what are we now going to have when we do this? Now we can square on both sides. Okay, so that we just remain with the cos x. So cos x in this case will just be equals to, because the square and the root will cancel, the square root of 16, that is just a 4, the square root of a 25, that is just a 5, and that is our answer. But now we're saying cos x is equals to this, but now we've been given a range of 90 to 180. So I'll go back again. All students take coffee. Then this angle we are saying is 90, between 90 and 180. It's in that region, and we are finding our cos to be this. We are saying in this region only sine is positive, so it means the answer that we found to be negative, because cos in that region is negative. Okay, so this is negative. So that's how you solve these ones. Let's solve b is tan x is equals to 2. X is a member of 0 to pi over 2. Pi over 2, that is 180 divided by 2, which is 90. So we want for just in the first quadrant, right? So tan x is equals to 2. Let's solve that one. Okay, so we are saying tan x is equals to 2. Okay, now since x is in the first quadrant, both sine and cos are positive. Okay, so we're going to use the identity of tan. We know that tan or tan x just equals to sine x over cos x. Okay, now we can make an equation here. Okay, so we can let sine x to be equals to a. We can also let cos x to be equals to b. Okay, then we solve. Okay, so we are saying tan x is just the same as sine x over cos x. So therefore to be sine x over cos x is equals to 2. Okay, now I'm saying sine a, we've let it to be a, sine x let it to be a, so this will be a over b is equals to 2. Now if you make a the subject of the formula to be a is equals to 2b. Okay, now let's use the Pythagorean identity. Sine squared x plus cos squared x is equals to 1. So what are we now going to have? We are saying a is equals to 2b, right? Okay, so we can replace that. So I'm going to say where there is sine squared, I'm going to put 2b. Okay, because a is equals to 2b, then this is squared. Okay, I'll ignore the x plus, when I come to the cos one, cos we're saying it is b squared, right? I'm going to put b squared, then it is equals to 1. Then we solve. Okay, so when this is squared, so this will be 4 squared, or it will be 4, then b also b squared, so it will be 4b squared plus b squared is equals to 1. Okay, now what do we now have? Now we've got 4b squared plus b squared. These are like them, so it's going to be 5b squared is equals to 1. Okay, for us to remain with our b, we are going to divide by 5 on both sides. So therefore your b, allow me to rub here. Okay, so we're going to have our b squared will be equals to 1 over 5. Okay, for me to remove the root, for me to remove the square, I'm going to square root on both sides. So therefore b will be equals to, you know that the square falls both on 1 and on 5. Okay, so b squared will be equals to, the square root of 1 is just 1 over the square root of 5. Okay, we found what b is. Now let's find what a is. We are saying a is equals to 2b. So if we're saying a is equals to 2b, so we're going to have 2 multiplied by b, which is 1 over the root of 5. Okay, so we're just going to have 2 over root 5 as our b. Therefore our final answer, since we had to let, this is a, since we had to let sine x to be equals to a and cos x to be equals to b, therefore our final answers now will be sine x is equals to a, our a is just 2 over the root of 5, then cos x, which is equals to b, the b we found to be 1 over root 5. So this is how you solve this one. Let's solve which one can we solve? Okay, we can also solve C. Cos x is equals to 1 over 3. X is a member of negative pi over 2. Negative pi over 2, that is 180 divided by negative, that's negative 90 to 0. Okay, so that is the range. So now what are we going to have? We're saying cos x is equals to that. So let's solve this one. So we are saying cos x is equals to 1 over 3. Cos x is equals to 1 over 3. And that is we've been given an interval. Now for us to find the value of x, you know that we just need to find the inverse. So in this case, to just x will be equals to, it will be cos inverse or arc cos 1 over 3. Okay, so this will be the answer. There's nothing much to solve here. Okay, so that's how we are going to approach this question. Now let's go to question number 3. Find the exact value of each of the following. Now all these questions we're solving, you are not using a calculator. Okay, you're going to be using your head to solve these questions. Okay, so find the exact value of each of the following. So the first one is cos 240 degrees. Okay, now how are we going to solve this one? You remember our special angles? Okay, we talked about 30 degrees. Okay, we talked about 45 degrees, which was like alone. Then 30 degrees, they go together with like 60 degrees in the equilateral triangle. So these special angles, they'll help us to solve these, to find the values of these ones without using a calculator. So how are we going to solve this one? Now 240, where are you going to find the 240? Let's say this is our y-axis, this is our x-axis. Or students, take coffee, don't forget that. This is 0,360. Okay, that is 0,360. 0,360. Then this is 90, this is 180, this is 270. Therefore our 240 will be in that region. Okay, so now what do we do? So because it's in this region, it means it will be negative, right? Because in that region only tan is negative. Okay, therefore our answer is supposed to be negative. Okay, whatever we're going to find is supposed to be negative. Now what can we do? Because it's in this region, we're going to subtract 180 from it. Okay, why are we subtracting from 180? Because we always measure, we said number one condition is that you're always measuring the acute angle. Acute angle is an angle that is less than 90 degrees. Okay, then you also measure, condition number 2 is that you are measuring this angle with respect to the x-axis. Okay, so if our angle is in this case, you're measuring that in that direction. Then if our angle, it is in this region, yes, you're supposed to measure this one, but because you're measuring an acute angle, this is more than 90 degrees, so it means you're getting the one that is on the opposite. That's why you're going to subtract. So now we're in this region, we're in the third region, this region. So the angle that we're supposed to measure, it is this whole thing, but now we're measuring an acute angle from this, so we're getting just this region. So for us to get that region, we're going to subtract this 180. Okay, so let's just do that. Okay, so we've got 240. So what are we going to have? Therefore this is just the same as 240 degrees minus 180 degrees, and when I subtract, I'm finding a 60 degrees. Now cos 60 degrees is just the same as we said, it's 1 over 2. Okay, so that is the answer. But now if this is the answer, we're saying it is in this quadrant, in the third quadrant, only tan is positive. So meaning our answer cos 60 degrees will now be equals to negative 1 over 2. So that's how we solve this one. Let's solve the second one. The second one is tan 120 degrees. Okay, and the tangent, this is 120. We are going to find 120. It's in this quadrant. This quadrant, it is the second quadrant. In the second quadrant, so this is quadrant 1. Okay, this is quadrant 1. This is quadrant number 2. This is quadrant number 3. This is quadrant number 4. Now in the first quadrant, everything, but now this 120, it is in this quadrant. Okay, and in that quadrant only sign is positive, meaning our answer is supposed to be negative, right? So whatever our answer will be supposed to be negative, okay, because only sign is positive in that quadrant. So let's solve 120, because it is, let's say 120, this is 120, and we said we're not measuring the whole angle, we're measuring the angle with respect to the x-axis, but which is an acute angle, so we're measuring that. So let's just do that. So it's for us to find that, we're going to do 180 degrees minus 120 degrees, and when you subtract that, you are just going to get a 60 degrees. Now tan 60 degrees, you know that is just the same as the root of 3 from our first question. Hello?
Hello?
Yes, please. Hello? Oh, it's called mommy. Okay, now tan 60, it is just, you know, the root of 3. And in which quadrant is it? We are saying it is in the this region. It is 120. It is in the second quadrant, and in the second quadrant only sign is positive. So it means our answer in this case is going to be a negative, you know, root 3. That would be our final answer. Okay, let's solve another one. Let's solve C. So we're finding sine of 300 degrees. So how are we going to do that? So we're going to do the same thing what we've just been doing. So sine 300 will just be the same as this is 300 is in which quadrant? 300, it will be in this quadrant, right? It's in the fourth quadrant. So we're going to subtract 360 degrees minus 300 degrees to find the angle in that quadrant. And when we do that, it just gives us a 60 degrees. Now sine 60 degrees is just equals to the square root of 3 over 2. So that is sine. But now in this quadrant only cos is positive, therefore our answer in this case is going to be sine 60 degrees now be equals to negative the square root of 3 over 2. Okay, so when you solve the let's solve another one. Which one are we going to solve? Let's solve D as well. 210. So cos 210. So 210, it will fall in this quadrant. So what are we going to do? We're going to subtract 210 minus 180. Okay, so what are we now going to have when you subtract those ones? That just gives us a 30 degrees, and cos 30 degrees is just the same as root 3 over 2. Okay, now in this quadrant 210, in this quadrant only tan is positive, so it means our answer in this case would be a negative. Okay, so that would be our final answer. We can also let's solve the last one on this part. Okay, the one that has pi. So E sine 7 pi over 6. So how are you going to do that? So first I have to convert the 7 pi over 6 to degrees Celsius, okay, so that you'll be able to solve. And you know that pi radians is just equivalent to 180 degrees. Pi and pi can cancel. 6 into 6 is 1. 6 into 18, that is a 30, into 18 is 3. You have a 37 multiplied by a 30. What are you going to have? 7 multiplied by 3, that is a 21, and you have a 0 at the end. So this is just the same as sine 210, okay. So allow me to write it there. So this is just the same as sine 210 degrees. Now sine 210 degrees, 210 is in this quadrant. So what are we now going to have? We're going to subtract 108, right? So we're going to say 210 degrees minus 180 degrees. Okay, this will give us sine 210 minus 180, we said is 30. So we're finding sine 30 degrees. Sine 30 degrees is just the same as a half, okay, or a 1 over 2. Now, in which quadrant is 210? Is in the third quadrant. In the third quadrant, only tan is positive. Therefore, our answer in this regard, it is a negative. So that's how you solve, this type of questions. Now let's, solve question number 4. Find the exact value of each of the following. Okay, so we're finding the exact value. Okay, finding the exact value. So let's start with the first one. We're saying sec 210 degrees. Okay, now second, what are we going to do? Let's solve this. Okay, so 210, we're going to go back to our quadrants. This is 90, this is 180, this is 270, this is 360 stroke 0. Okay, okay, then all students take coffee. Okay, now 210, it is in this quadrant. Okay, in this quadrant only tan is positive. Okay, everything is negative, so it means our answer that we're going to give is going to be negative. So let's just do that. Sec 210 will just be the same as 210, because it's in the third quadrant. We're going to subtract by 180 degrees, and when we do that, we're just going to have sec 210 minus 180, that is just a 30 degrees. Okay, now sec 30 degrees, now you have to go back to your cos 30 degrees. You know that sec and cos, they have got a relationship, they are opposites of each other. So if cos 30 degrees is just the same as the root of 3 over 2, therefore our sec will be the opposite, right? It will be 2 over root 3. But now look at it, is in which quadrant? It is 210 in this quadrant. In this quadrant only tan is positive. So what are you going to have? Our answer will finally be a negative answer. This will be our final answer in this case. Okay, let's solve B. Now for B, we are told to find cot. We're finding cot 225. Okay, so 225, we're just going to do the same. It's in this quadrant as well. So what do? We're going to subtract 225 minus 180, and when you subtract that, what do we get? You're going to get, on my end, I'm getting a 45 degrees. Okay, now this is 45 degrees. Cot, cot has a relationship with which, trigonometric ratio. Cot has a relationship with tan. So tan 45, what is tan 45? You just know that tan 45 is just a 1. Therefore our answer in this case is going to be, a 1. But now, because the opposite of 1 is just 1, right? Or 1 over 1. But now, in which quadrant is this? It is in this quadrant. Tan in this quadrant is positive. Okay, so if tan is positive and these ones, they are the opposites of each other, so our answer is just going to be a 1, like that. Then we come to C. see we are solving cosec 315 degrees. So cosec 315 degrees. So what are we going to do? 315, you know, it's going to fall in that region. So what are you going to do? You're going to say 360 minus 315 degrees. And when you do your math, what are you going to have? You're going to have a 45 degrees. Okay. Now cosec goes together with sine, okay, because they're opposites of each other. So sine 45 degrees is the same as you know, it's root 2 over 2. That is sine 45. Therefore our cosec in this case will be, or our final answer is going to be the opposite. It's going to be 2 over root 2. But now let's look at the sine. What is going to be the sine? Okay, this is the fourth quadrant. In the fourth quadrant, only cos is positive, so this becomes a negative, and that will be our final answer. Okay, now what about D? So how do we solve D? Wait. Then we have sec 300. Okay, sec 300, how are we going to solve this one? So sec 300, what is it going to be? 300 is in this region, so because 300 is that region, we're going to subtract from 360. So 360 minus 300, that just gives us a 60 degrees. Now sec, we said it goes together with you know, cosec or cosecant. Okay, so sec goes together with cos. Now cos 60 degrees is just the same as 1 over 2 from your special angles. Now what is going to be the answer, therefore, to be the opposite of this? So therefore our answer, sec 60 degrees, will just be equals to 2. Now this is in this quadrant. Cos is positive in that quadrant, okay, because cos is positive in that quadrant, so this is also going to be a positive 2. Okay, so that's how we solve, you know, such kind of questions. Let's solve some, use compound angle identities to find the exact value of the following. We are using compound angle identities. Okay, so what do we mean compound angle identity? You are adding, let me say, adding or subtracting two angles to come up with double angles. Okay, so what are we going to have? Let's solve the first one. We've got sine of 15 degrees. Now you're not solving it the way we've been solving it previously. You're going to be using compound angle identities. Okay, so what are you going to do? You know that 15 degrees is not really like a special angle that you can find. So 15 degrees is just the same as, you can get 45 degrees that you know minus 30 degrees. You know that this will give you a 15. Okay, so that's the one that we're going to get. So this is just the same as sine, you know, A minus B. Okay, and you know that sine A minus B is just the same as sine A multiplied by cos B. Then you're going to have your minus. Now it will be cos A. It is going to be cos A multiplied by sine B. So that's what we're going to do. So we're having sine, we are saying 45 minus 30. So this is just going to be that. Okay, so this will be sine 45 cos 30 degrees minus, now you're going to start with cos, so this will be cos, it's going to be now cos A. What have I written? Is this correct? Yes, it's going to be cos A, that is 45. Then you have sine B, which is B. What is our B? That is our 30, like that. So now we just have to solve this one based on what we know about special angles. what is sine 45, what is cos 30. Okay, so those are the things. Now you know that sine 45 according to your our triangle, you remember something like this. So this is 45, this is also 45. Okay, this is a 90 degrees, this is a 1, this is a 1, this is root 2. And if you're finding sine 45, we're saying sine is equals to opposite is 1 to 45 over hypotenuse, which is just a 2. So that would be our sine. Okay, so sine 45 is just the same as 1, over root 2. Okay, so that is sine 45. Is it really 1 over 2? Okay, so that is going to be root 2 over 2. And then we come to the other one. Cos 45, we have got what? Cos 30. Cos 30, what was cos 30 in that regard? Cos 30 was just cos 30 was the square root of 3 over 2. Okay, then what other thing are we supposed to know? Because there's also sine 30 here. Okay, so allow me to write them nicely so that we don't get confused. So let me start with the one for sine. So we have a sine 45, we have a sine 30, then we have a cos 45 and a cos 30. Okay, so let's just put these ones to guide us so that we don't make a mistake. Sine 45 is just the same as root 2 over 2. Then sine 30 is just the same as that this one is common, 1 over 2. Then cos 45 is just the same as root 2 over 2. Okay, then cos 30 is just the same as cos 30 is just the same as root 3 over 2. Now I'm writing sine 45 to be the same as root 2 over 2 because you know that your angles, when you're dealing with surds, don't put a surd down. Okay, whether you're dealing with, even in as much as we're still talking about trigonometry, don't put a surd down. Okay, you know that sine 45 is the same as 1 over root 2. Now you don't want to have a root 2 down, so you're just going to do multiply by the root 2 on both sides so that you cancel the root 2 down. Okay, so you're going to have the root 2, and the root 2 with the one on top, they are going to divide, and that's the interpretation there. Okay, that's why I'm writing them like that. So now let's solve. What are we now going to have? Sine 45, cos 45. So our job is just going to be, we're just going to be replacing. Okay, so let's start. We've got sine 45. Allow me to use a different color. Sine 45, we've said is root 2. So root 2 over 2. This is multiplying by cos 30. Now cos 30, we've said it is root 3 over 2. Then minus, on the other side we've got cos 45. Cos 45 we said is root 2 over 2, or 1 over root 2, which I haven't written. Then sine 30 is just the same as we've put 1 over 2. That is a common one. Okay, then you just have to simplify this, then you're done. So allow me to rub this thing that has been guiding us, these ones that have been guiding us. So what are we now going to have? We're just multiplying what we have, okay? Root 2 multiplied by root 3 on top, you know that's just going to give us root 6 over 2 multiplied by 2 down, that will just a 4. We're subtracting with root 2 multiplied by 1 on the other side is just root 2 over 2 multiplied by 2, that is a 4. Because you have the common denominator, what are you going to have? You're just going to subtract what is on top. Root 6 minus root 2 over 4. So that is going to be your final answer. So that's how you solve the first one. Let's solve the second one as well. So we're solving cos 15 degrees. Okay, so it is the same principle. We are going to get just the same. This is just the same as 45 degrees minus 30 degrees. Now for cos, if you've got cos A minus B. So if you've got cos A minus B, you know that this is just the same as cos A cos B minus, and after you minus, you know that this excuse for that. So cos A cos B. Now the symbol in this case, this is a minus. For cos the symbol changes, so you put a plus. Okay, when you put a plus, then what are you now going to have? You're going to have sine A sine B. Okay, then you solve. In this case we've got 45, so we're finding cos 45 minus 30, which will give us cos 45 cos 30 plus sine 45 sine 30. And we're just from talking about these ones. Okay, so what are we going to do? We're just going to replace. Okay, so cos 45 we said is just the same as, you know, root 2 over 2. This is multiplying by cos 30. Cos 30 is just root 3 over 2. Then there is a plus here. Then what do we have on the other side? Sine 45. Sine 45 is root 2 over 2. It's just the same as cos 45. Then sine 30 is just 1 over 2. Then you simplify. When I multiply what is on top on the other side, what do I get? I've got a 6 over 2 plus, when I multiply what is on the other side, that will get root 2 over a 4. Okay, even this one is a 4. Then it means what I'm just having on top, I'm just adding them. Okay, so I'm going to have root 6 plus 2 plus root 2 over 4. So that would be my final answer. Now you're able to see that these ones are giving you the same answer. Okay, it's just that one is negative, the other one is positive. Okay, so that's what you are going to do. Which other one can we solve? Let's solve D. D, we are saying evaluate sine 165 degrees. So what are you going to do for 165? So you know that 165 is just the same as 180 degrees minus a 15 degrees. Okay, why am I putting 180 and why have I chosen 180? You know that 180 sine 180 is something that we know. Okay, so what are we now going to have? From the result that we got, 165 and 180. since 180 minus that is equals to sine theta, what are we now going to have? This is just the same as so 165, because if we're subtracting from 180 we subtract a 15, that means that this is equivalent to 65. Okay, so sine 165 is just the same as 15 degrees. Okay, yes, it's just the same as 16 degrees. And we found what 15 degrees, sine 15 degrees is, we said it is just the square root of 60 minus the square root of 2 over I think that was a 4. Yes, so that's what you are going to do. You're going to look for a number that you can subtract from, because you know that this is in the second quadrant. Because in the second quadrant you're going to subtract from 180 so that you find the angle with respect to to x, which is this, the acute angle, and that's the one that you're going to solve. And we've solved it early when we're starting, and we found that. So that's how you solve these questions. Let's go to question number 6. So how do we solve question number 6? Given that a is that given that sine a is equals to 4 over 5, where 90 degrees, where a is between 90 degrees and 270, and that cos b is equals to negative 5 over 13, where 180, b is between 180 and 360. Find the exact value of the following. Okay, this is not much different from the first equations that we're solving. So we've been given sine a, we've been given cos b. So let's just do something here. We've been given sine a, which is just the same as 4 over 5. What other information have we been given? We've been given cos b, which is negative 5 over 13. So it means it will be our job to also find sine b, which we have been given. It will also be our job to find what cos a is. Okay, so that it becomes smooth for us to solve the other questions. So we can solve in advance. Then you know that according to your Pythagorean identity, you know that if you've got, let's say, sine squared x plus cos squared x just equals to 1. And in this case, if we're going to make cos, let's say in this case, since we're trying to let's find cos a. So if you're going to find cos a, so it will be cos squared a will be equals to 1 minus sine squared okay, so minus sine squared a. Now that we've got that, if we square root on both sides, here I'm going to remain with cos a will be equals to be the square root of 1 minus sine squared a. But now let me look at the angle. Okay, if we look at this, sine is positive here, 4 over 5, sine is positive. Okay, and it must be probably in the second quadrant. Okay, so from this you're able to see that now in the second quadrant cos is negative, so this would be a negative. Then when we come to the other side, if we're going to find cos b, what are we going to do? Let's now find the sine. Okay, so our sine squared of x will just be equals to 1 minus cos squared of x. In this case, let's put b. Okay, since we're finding b, for me to find sine b, I'm going to square root on both sides. So this will be the square root of 1 minus cos squared b. Then what will be the sign or the symbol for this? And what would be the symbol for that? Okay, so what do we have? Is it going to be negative 5? Okay, it's already negative, so it's a negative here, so this would be a negative actually. Okay, so now that we've got these answers, let's also find the actual the actual values, because we've been given what sine A is. So what we're just going to do is, where there is sine A here, we're replacing. Where there is cos B here, we are placing with this cos B, so that we find the exact value of these answers. Okay, I can start with this, the one that is here. So the square root of 1 minus cos B. So what are we going to have if we're going to find our sine B? Why have I put sine B here? I'm supposed to find cos A cos B. Okay, this is cos B, and we're finding cos A. Okay, so cos A, we found it is this side. Okay, so allow me to rub on top here. Okay, since cos A is that, so how are we going to solve our cos A so that we find so we're going to do this will be equals to the square root of 1 minus, allow me to, okay, the negative, let me just put it. We've got sine A. Sine A, it's 4 over 5. This is squared. Okay, don't forget that. So if we're going to find our cos A, this is negative 1. Then if we square 4, that is 16. If we square 5, that is a 25. Okay, then if we solve what is in the bracket, what will now give us our cos A? Allow me to rub now what is down to find our cos A. So what are we now going to have? 1 minus 16 over 25. That just gives me negative the square root of 9 over 25. Okay, now that I've got that, what do I now have? The square root of 9, so I'm going to have negative. The square root of 9 is a 3. The square root of a 25 is a 5. So we found our cos A. Okay, now what about its counterpart? Okay, cos B. Okay, cos B. What are we going to have? So on this other side, I'm going to do the same. 1 minus cos B, we've been given this cos B, it is negative 5 over 13. Okay, this is squared, don't forget the square. So we're going to have negative the square root of 1 minus 5 squared, whether it's negative or positive, is just going to give us a 25. Okay, a 25 divided by 13 squared. 13 squared, what is it going to give us? It's going to give us 169. Okay, now when I solve this in the bracket, I'm getting on 144 over 169, and when I do the square of those ones, I'm getting my cos B to be equals to negative 12 over 13. So we found cos A, we found cos B. We have sine A, which they've given us. We have cos B that they've also given us. Okay, so now what is our job now? Our job will now just now to be solving these ones. Okay, so we're saying negative 3, so cos allow me to write it on the other side. Allow me to write it on the other side. So this is, we said it's negative 3 over 5. Then what other thing did we find? We had to find the sine b. Okay, this is sine b. From this sine b, we found that it was negative 12 over 13. So these are the the answers that you're going to be using to be solving those ones. So let's now solve. We have everything. Okay, then cos b we've been given. Cos b is negative 5 over 13. Sine where is it? Sine a is equals to 4 over 5. So let's start with the first one. The first one, we are solving a, which is sine a plus b. So how do we solve this one? You know that sine a plus sine b is just the same as sine a multiplied by cos b plus cos a multiplied by sine b. Okay, so that's what we're going to do. Now we've already found what our sine a is and our sine b, everything we have. So it is just a matter of putting everything together. Or if we want, we can solve this separate and we solve that one separate, then we add the two. Okay, I think that one will also be easy. So if we've got sine a, which is multiplying by cos b, so what are we going to have? Our sine a, it is 4 over 5. This is multiplying by cos b. Cos b, it's negative 5 over 15. Okay, so when we solve that, 4 multiplied by negative 5, that is a negative 20 over 5 multiplied by 15. 5 multiplied by 5, that is like 25. Okay, 75. So we have a 75. Then the other part that we are solving is cos a sine b. So what is our cos a? We just found that it was negative 3 over 5. This is multiplied by sine b, which is negative 12 over 13. So we're just solving those ones. Negative 3 multiplied by negative 12, that is like 36 over 5 multiplied by 13, that is like 65. Okay, so these are two answers, so we just need now to add them. Okay, allow me to add them. Okay, so we have negative 20 over 75 plus 36 over 65. Okay, so our duty is just to solve this one. So, and you find the common denominator and we solve. So what will be our common denominator? I think I made a mistake somewhere. Okay, so cos b, this is not 15, this is a 13. Okay, from here, this is not a 15, it's a negative 5 over 13. So I'd written negative, I thought like this is 13. Okay, I thought like that is 15. So this will also give us a 65. Pardon me for that one. So on both ends we've got, we've got 65. Okay. So what are we going to do? We're just adding the two. So they both have the common denominator of 65. So what did we have? So we were adding negative 20 over 65 and plus 36 over 65. And because they have the common denominator, this will be 65. Negative 20 plus 36, That just gives me is it a 16? Yeah, a 16, like that. So this will be the final answer. So let's solve the next question. Okay, because we got everything now, so we're finding b. B is cos a plus b, and you know that cos a plus b is just the same as cos a cos b. For cos, the sign changes, so it will be minus. Then you're going to say sin a sin b. Okay, so let's just do that. So what are we going to have? Let's replace cos a. It is negative 3 over 5. This is multiplying by cos b. Cos b, that is negative 5 over 13. Let me not make a mistake on 13 again. Then I've got sin a, which is 4 over 5. This is multiplying by sin b, which is negative 12 over 13. Okay, then we're just going to solve. Negative 5 multiplied by negative 3, that just gives me a 15 over 5 multiplied by 13, that is a 65, like we've been finding. The other side, 4 multiplied by negative 12, what do I have? A negative 48. So what am I going to have? I'm going to have a negative 48 over 5 multiplied by 13 is a 65. Then what am I going to have? 65. 5 plus 48 on top, because the negative and negative is going to give us something like a positive. So what are we going to do? 5 plus 8, that is like 13. Is it 13? Then 1 plus 4 plus 1, that is like a 63. Okay, so that is going to be our final answer, 63 over 65. And that's what we're going to do for the other ones. Okay, let's go to the next question. Given that cos x is equals to 3 over 4, and that x is between 180 and 360, find the exact value of the following. Okay, this is very, very interesting. Double angles. Okay, so what are we doing? We are given, let's start with the first one. We are finding sin 2x. Given that cos x is that, and find the exact value of that. So they've only given us cos x, and they're saying cos x, let me write it here, cos x is equals to 3 over 4. So what do we do? So in this regard, we can use our to find sine, because it'd be hard for us to find sine. So let's use our identity, which we say sine squared x plus cos squared x is equals to 1. Okay, and if we're going to find our sine squared x will just be equals to 1 minus cos squared x. Then what do we do now? 1 minus, what is cos squared? Cos just alone, cos is 3 over 4. Then this is squared. Okay, so we have 1 minus 3 squared, that is a 9, minus then 4 squared, that is a 16. 1 minus 9 over 16. What do we have? If I put a 1 here, 16, 1, that would be 16 minus, that is 9. Okay, 16 minus 9, that is like a 7. Okay, so our final answer is 7 over 16. So 7 over 16 as our sine squared x. But now if I want to now to remove the the root, I'm going to have sine x will be now equals to the square root of that. So now that I've found that, so now I can solve. That sine 2x, this is just a double angle formula, and the double angle formula for sine 2x, that it is just the same as 2 sine x cos x. Okay, and where this one comes from. If you go sine a plus a, because they are the two of them, you're going to get that kind of an arrangement. Okay, because you're going to say sine a cos a plus cos a sine a, and these are the same, so I'm just going to add them to be 2 sine a cos a. So that's where that one is coming from. So you have to know this one is. So what do we now have? So from this, what do we now do? We're just going to now replace. Okay, so we're going to say 2 multiplied by sine x. We've already found it is the square root of 7 over 16. This is multiplying by cos x. Cos x is already given 3 over 4. Then you solve. Okay, so what do we get when we simplify this expression? Okay, so 2 multiplied by 7, what do we get? So these 2 can divide, 2 can go into 4, we're going to remain with 2. Okay, and when we have that, what other thing can we multiply? Okay, this is 16, right? Okay, anything that we can do here is just multiplying these. So what is there to do now? Or before I do that, 2 multiplied by 3 on top, that is like a 6. The root 7 over 16 multiplied by the 4 down. Okay, 16 multiplied by the 4 that is down. Or what am I going to do? Okay, so what I'm going to do is, because this is a square root of 7 over 16, I can write it as sine x is equals to, the square root can go on 7, the square root of 16 down, we know that it is a 4. Okay, now we've also been given a range 180 to 360. 180, you know that sine is only positive in the first and the second quadrant, so it means this, our answer, it will be a negative. It's good that we even went back. This will be a negative because in that region sine is negative. Okay, so what do we now do? We are going to have 2 root 7 over 4 multiplied by 3 over 4. Okay, 2 and 2 can divide, that will give me a 2. Okay, therefore I'm just going to have what am I going to remain with? This is 2 over that. Yes, then let me just multiply what is on top. 2 multiplied by 3 on the other side, that is like 6. Now this is a negative, don't forget it as a negative, so it will be negative 6 over root 7, then over, then the 4 and the 4 and the 4 multiply, they will give us a 16. So that will be the answer if you want to leave it there. Okay, and if you want to simplify it further, you can divide by 2. 2 can go in here to give you negative 3, and 2 can go in there to give you 8. So this will be negative 3 root 7 over 8. Okay, whichever way that you want. Okay, 2 multiplied by 4, it will give you still 8, and the other way around. So that's what we're going to have for this one. Okay, so that is the first one that we've solved. Let's solve the second one. Now we're solving b. B is sec 2x. So how are we going to solve our sec 2x? So for us to be able to solve this one, you know that sec goes together with cos. Okay, and since we're talking about double angle formulas, the double angle formula for cos, you know that cos 2x is just the same as cos squared x minus sine squared x. So cos has got about 3 formulas, so you have to know all of them. Okay, it's very important. So we can also try to use, you know, this one, because we've been given cos x. Okay, so what do we do? So we are going to say cos 2x will be equals to, why am I using cos 2x? Because there's sec 2x here. So what do we now do? You know that cos they've already given us cos, which is 3 over 4. This is squared. Okay, minus sine squared x is the one that we just found. Sine squared x, sine squared x, I think that was it the square root of 7 over 4? Yes, so we found that, so we are going to put it here. It was negative, don't forget, because of the quadrants, the square root of 7 over 4. Then our job is just to solve this. So we're going to have 3 squared, that is like a 9, 4 squared, that is like a 16, minus, or let me just put, okay, minus, then the square root of 7 over 4. Then what do we have? The square root of 7 over 4. Okay, so this is squared actually, so I forgot to do the other side. So the square root of, because there's a negative, the negative is going to cancel. The square root of 7, that will just be 7 over the square root of 4 down. We're just going to have a 16, and because of the common denominator be 16, 9 minus 7, what do we have? It is just a 2. Okay, and a 2 over 16, that is just 1 over 8. Okay, so that is the answer for cos 2x. Now if cos 2x is equals to 1 over 8, what will be sec 2x? Sec 2x to be the opposite, it will just be what? 8. Okay, and it is positive. Okay, because of the what we've been given here. Okay, now let's solve, which other one can we solve? This is let's solve the last one. Let's solve something to do with tan. So how are we going to solve for tan? You know that tan, you know, 2x. Now this is tan 2x, so this will be the same as sine 2x over cos 2x. Well, just from finding sine 2x, sine 2x we said sine 2x, what did we say that was? It was the first, the answer to the first question. Okay, negative 3 root 7 over 8. This is divided by cos 2x, which we are just from finding, which was 1 over 8, and we're just solving like that. So what are we going to do? You know that this one will change, 8 will go on top and the 1 is going to come down, and the 8 and the 8 can divide. Okay, you're going to just remain with the root 3 over 7. Okay, so that's how you solve this one. Very simple and very straightforward. Now let's prove some identities. So question 8 is about proving the identities. Prove the following identities: cos that is equals to that. Okay, cos 2x. So proving identity is very simple, because you are just comparing what is on the other side with what is on the other side. So cos 2x is equals to 1 minus 2 sine x. Now this one we've been solving about it very because we are saying cos 2x, the identity that I gave you was cos squared x minus sine squared x. Now we wanted to have a sign here. Okay, so I'm using the left hand side to give us the right hand side. Okay, because there's a sign here and a sign, so that's my target. So I have to find what cos squared x is, and you know that from your identity, cos squared x is just the same as 1 minus sine squared x. So allow me to put it there. So I'm going to have cos, okay, since we're replacing that with what I've just written, so I'm going to have 1 minus sine, what am I writing? Yeah, 1 minus sine squared x, this minus the sine squared x that is at the end. So now I'm going to have 1 minus sine squared x minus sine squared x. Don't multiply this, because this it's just, there's nothing like multiplication. We're just adding these things. So what are we now going to have? We've got 1 negative sine squared minus sine squared. So these ones are just going to give us negative 2 sine squared x, which is equals to the right hand side, hence proven. Okay, so this is very straightforward and very on point. Then let's solve another one. Let's solve b. Now for b, we're given sine 2x is equals to 2 sine x cos x. I think we talked about this. Okay, so we said if you're given sine a plus a, or let me put x, because you're finding 2x, right? If you're given sine x plus x, you know that for sine you're going to say sine x cos x, plus you're going to say now it will be cos x sine x. Now because multiplication is also commutative, provided the things are the same, okay, you're not changing anything. This can be written as sine x cos x plus sine x cos x if you want. Okay, it's just the same. If you say 7 times 3, is it the same as 3 times 7? It's the same thing. Okay, so that's what we're going to do. And when you add these, because these are the same, you're going to have 2 sine x cos x. So here it's already a proven identity. There's nothing much that you're supposed to do on this part. Okay, so let's solve another one. Let's solve c. So for c, we are finding cos 2x is equals to 2 cos squared x minus 1. So what do we do? Which one can we get in this case? So this is cos 2x. So this is a double angle formula. Okay, now we want it to have cos. Okay, so that is our target. Okay, so we're going to be going from the left to the right. So we want it to have that, and we said cos 2x is just the same as cos squared x minus sine squared x. Okay, what am I going to do? because I wanted to have this 2 cos squared x, so it means this one I can make cos the subject of the formula. Okay, so what am I going to have when I do that? Sine squared x, you know, that's just the same as 1 minus cos squared x. Okay, so this is what I'm going to put there. So I'm going to have cos squared x minus, then I have 1 minus cos squared x. Then I solve. So I have cos squared x. Now the negative can distribute. I have negative 1 positive cos squared x. Then when I have that, this is the same as that, so they can add. So I'm going to have 2 cos squared x minus the 1 would have now proven to that, hence proven. Okay, so that's how you solve these proving these identities. Nothing hard, just know your identities in and out, then you are good. Okay, which other one can we solve? Let's solve G, the last one. Okay, for the last one, it's giving us a constant. Okay, I think this one is a good one. Sine x minus cos x, this is squared, plus sine x plus cos x, this is also squared. So what are we going to do now? Okay, so I think I've seen where the mistake is when we are squaring. Okay, so this squared, when we square with this, okay, when we square cos, but because there's a negative there, this will also be a positive. Okay, then we've got that. So we're just going to now add the like terms. So we're going to have 2 sine squared x plus 2 cos squared x. Okay, then what are we going to have? We can factor out the 2. This will be 2. In the bracket, we're going to remain with sine squared x plus cos squared x. Now this will give us 2. What is in the bracket? You know that all of it is just a 1 according to your Pythagorean identity. 2 multiplied by 1, that is a 2, hence giving us that 2. Okay, let's solve another question. Solve each of the following equations from that range to from 0 to 2 pi. 2 pi, that is just like 360. Let's start with the first one. So we're saying sine 2x minus sine x is equals to 0. So how do we solve this equation? Okay, sine 2x. Now you know that sine 2x, you just have to write its double angle identity. Sine 2x, we said it's just the same as 2 sine x cos x. Then we're subtracting this with sine x. This is equals to 0. Then when you have that, what are you going to do? We can factor out, we can factorize. Okay, so what are we going to do? We are going to have sine x, we're going to remain with 2 cos minus 1 is equals to 0. Okay, so now what do we have? So therefore our final answer will be sine x will be equals to 0. Then we also have 2 cos x minus 1 is equals to a 0. So in this case 2 cos, when the 1 goes to the other side, it will be a positive 1. Then when I divide by 2 on both sides, okay, so there's an x that is there, so cos x is equals to 1 over 2. So these are the answers that we have. Now sine is 0. Where else is sine is 0? From our, from that table that we solved at first, sine is 0. Sine x can be 0 at just 0, 0. Then you can also have at sine is also 0 at 180 80. So sine, we have two answers, 0 and 180. Let's come to cos. Okay, now for cos, we found that cos x is equals to 1 over 2. Now 1 over 2 in terms of cos, what is it? Okay, in terms of cos, 1 over 2. 1 over 2, you know that is just 60, right? So cos x is 1 over 2. So for us to find x, it will be cos inverse of 1 over 2. And therefore x is a 60 degrees. Now look at the answer that we've been given. The range is in radians. So you also have to make sure that your answers are in radians. So 60 is just the same as what? 60 is just the same as pi, which is 180 over, to make it 60 to be 3. Okay, 180 over 3 gives us a 60. So x is pi over 3. Now this is from 0 to 360. 60 is a positive, where else is cos positive. You know about your quadrants. All students take coffee in the last quadrant. Okay, in the third in the fourth quadrant. So it means from 360 we have to subtract a 60, which will give us a 300. That's another answer. So a 300 in terms of radians, what are you going to do? This is just the same as what? Let's say pi over 3. For it to be that would be 100, that would be like 60 multiplied by a 5. That gives us 300. So these are the answers. Therefore our answers are going to be x will be equals to, number 1, we found that x is equals to 0. X is equals to also to 180. Okay, 180. X is also equals to 60. Let me put them in order. So pi over 3, that comes is 60. Then what comes is 80 or 180. 180 is just the same as pi, comma, then 300, which is 5 pi over 3. So this has 4 answers. If you write 2, you get half the marks. Okay, so that's what you are supposed to know. So that is very important for you to know. Let's solve B. So B is sine 2x is equals to cos 2x. Okay, now this is very, very interesting. Okay, so what can we do in this case? Let's divide by cos on both sides so that we have tan. So if I divide by cos, if I divide by cos 2x on both sides, even this side cos 2x, this side I'm going to have tan x is equals to, on the other side this will just give me a 1. Okay, so we've got tan x or tan theta is equals to 1. Okay, so now where is this theta equals to 1? You know that where tan is equals to 1, we said it is 45. Okay, so 45 degrees in terms of tan is the one that gives you a 1. And when we express this one in radians, we said it's just the same as pi over 4. 180 divided by 4 gives you 45. So this is our answer. So the first answer is 45. Where else is tan positive? All students take coffee. Tan is positive in the third quadrant. Okay, so in the third quadrant, what are we going to do? So we're just supposed to add again another one. Okay, So we're going to add, okay, don't forget this is tan 2x. Is it tan 2x? Okay, yes. So this is tan 2x, not just tan x, okay? So this is tan 2x. Okay, so tan 2x is equals to 1. Okay, now we found the 45. How are we going to find another one? So if you want to find the one that is in the, you know, in the next quadrant, so what do you do? So we have 45. Okay, so which other one are we going to have? So 180 plus let's say in this quadrant you want that angle. Okay, so to be, this is 180. Okay, so what is that angle? So now what do you now do? If we're going to solve this one, pi over 8, so that, what is it going to give us? Okay, sin 2x. Now what the 2x means is that to this 45 that you found, okay, and if we're going to get our 270 minus 45, I'm going to have this is in the third quadrant. I'm going to have 6. This is 1. That is would be like 5. That would be like, is it 6? Okay, 6 minus, that is 2. So 225. So these are the two answers that we have. Okay, 225 and 45. So this is the first revolution. That's what it means. Now if you have a 2x, what it means is like this. You're going to move the first revolution. You found the two answers, but because there's a 2x, again you're going to do another revolution, and you know that another revolution is just a 360. So to each of these ones you're going to add the 360. Okay, so I'm going to have 45. I'm going to have 225. Then to 45 I add 360. To 225 I also add 360. Okay, so our 45 plus 360 plus 45, that is 5, that is 10, that is like 4. Is it? Okay, yeah, something like 405. Okay, so you're going to write these ones in radians, don't forget. So then you've got 225 plus 360, that is 5, that is like 8, that is like 5. Okay, so this is 585. Okay, so 585. But now don't forget that you're finding 2x. So because you're finding 2x, what will be x? So you're going to divide everything by 2. Therefore x will be all the answers that you're going to get after, you know, so 45 divided by 2, that is 22. Is it 22.5? Okay, then 225, that is 1, that is like 2.5. okay, when you come to the other side, that is 20, that is 2.5. then you're going to have 2 into 18, that is like 9, then 2.5. okay, so these are like half, the half of 45 in terms of pi radians. If pi radians, the half of this is what we have, because 2 is like halving them. Okay, the half of that is just be pi over 8. So our answers in radians, x x will be equals to the first one is going to be pi over 8. Okay, when you half that one, then what about the next one in radians? How is it going to be? I'm going to have 5 pi over 8. The other one I'm going to have 9 pi over 8. Then the other one I'm going to have 13 pi over 8 as well. So those will be our answers. So that's how we solve, equations. Very simple and very straightforward. Okay, then find all the solutions of the equations in the interval that. Okay, so how do we solve this one? So it's not very much different from the previous one. We've got 2 cos 3x is equals to 1. So what are we going to do? I can divide by 2 on both sides. Okay, so that I just remain with cos 3x is equals to 1 over 2. Now 1 over 2 in terms of cos is what? Okay, you just know that 1 over 2 in terms of cos, that is something like it's a 30 60. So this, it is a 60 degrees. Okay, so if it's a 60 degrees and 60 degrees, it is in the first quadrant. Where else is cos positive? So this is our first answer. Okay, this is our first answer. Where else is cos positive? Or students take coffee. You're able to see that it's in the fourth quadrant. So for you to find what is in the fourth quadrant, 360 minus 60, that will give us 300. So this is another angle. So we've got 2 angles. So cos 360 or 3x is thus equals to, we've got 60 degrees as the first one, we've got 300 degrees. Now to these ones, what 3x means? It means you've already made the revolution. Let's say it's like this. You've already made the first revolution. Now you're making another one, and you're making the third one. Okay, so that's what we are going to do. So we've already found this one as our first revolution. So now to these ones we're going to add another revolution, which is 360. So to each of these ones, let's add 360. So to 60, when I add 360, what am I going to have? Okay, so 360 plus 60, I'm going to have 0 2, that is like a 4. I'm going to have 420. Now I also need to add the 360 to 300. When I add a 360 to 300, what am I going to have? So this is 300, this is 360. I'm going to have 0, 60, and 6. I'm going to have 660. Okay, we've made the second revolution. Now when we make another one, we're going to get again these answers that we had in the previous revolution, and we're going to also add another 360, the last one. Okay, so this is 360. So 0, that would be 8, that would be a 7, right? Yes. So allow me to write 780, comma. Now when I add to the other one, 660 plus 360, so 660 plus 360. That is like 12, that is like 9, 10. Okay, 1020. Okay, pardon me, I haven't written them in radians. Okay, so maybe let me first divide by 3, because now that we found these are the answers, but now we're finding x, we're not finding 3x. So we're going to divide by 3 throughout. Okay, therefore now our x will be 60 divided by 3. What is it going to be? That is like a 20, right? 300 divided by 3, that is like 100. 420 divided, that is 1. That would be like 40. That would be like 220. That would be like 260. That would be like 3 into 10, that is like 3. Remember 1 into 12, that is like 4. 40. Okay, at least for this one we've already been given the interval in terms of degrees, so these ones are correct. So they want the range from 0 to 360. Okay, from 0 to 360. So these will be our answers, and to everything it is the same principle like we've solved on the previous questions. Okay, now this is very interesting. No exam, you have to know how to sketch the graph of the following trigonometric functions. In each case, state the period, amplitude, and the vertical shifts. Okay, so these are very, very simple and very straightforward. So what are we going to do? Let's start with the first one. Y is equals to 3 sine of x. Okay, allow me to write it on the next page. So we are saying the first one, A is y is equals to 3 sine x. So we're trying to find the amplitude. The amplitude is how high the wave goes. Okay, so we're also trying to find the period. Okay, then we're also trying to find what are we finding? We're finding the vertical shift. Allow me to abbreviate it as VS. Okay, so what do we now do? The amplitude is how high a graph moves. You know that a sine graph, if this is just a model, you know that it alternates between 1 and 2. But now the amplitude is the number that is attached in front of the expression or the equation. In this case it is 3. So the amplitude is 3. Okay, the graph will reach as high as 3 and as low as -3. Okay, then the period, the way we find the period is equals to 2 pi over b. B in this case, it is the number that is attached to x, the coefficient of x. The coefficient of x, you're able to see that it's just a 1, not sine, no. The coefficient of x itself is 1. So 2 pi over b, or 2 pi over 1, which is just the same as 2 pi. So this is how that's how shows how many cycles is going to take. It's going to take about 2 pi. Okay, so now that we've got this information, we have everything that we need for us to graph. Okay, let's say this is our y-axis and this is our graph like that. So how do we now solve this one? We are saying this graph, the period, it ends at 2 pi. Now the half of 2 pi, you just know that it is just pi, right? So this is pi. Then between 0 and pi, what are you going to have? You're going to have pi over 2. Between pi and 2 pi, you're just going to multiply pi over 2 multiplied by 3 if you want, or you add pi plus 2 pi, then you divide by 2, or you just get this one and multiply by 3. So it's going to be 3 pi over 2. Now that we've got this, you know that the sine graph, it goes up and it comes down. Okay, so our amplitude, we've said it is 3, so even on the other side it will be -3. So it's going to be alternating between 3 and -3. Now because the value of its, the function itself, it is positive, so it's going to go up. So it's going to pass through this point. It's going to pass through 180, and it's also going to pass through 360. So it's going to go up and it's going to come down like that. Okay, so when it goes, so our graph is going to go like this. This is the graph of 3 sine x. Very straightforward. Now let's solve another one. The next one is y is equals to sine over, is it x over 2? Okay, so let's just do that. So we have sine y is equals to sine, it's a function, y is equals to sine x over 2. So how are you going to do this one? It's the same, drill. We're finding the amplitude, we're finding the period, we're also finding the vertical shift. Now the amplitude, we say it's how high. Now you're able to see that for this graph, what do we have as the coefficient of the function itself? It's just a 1, okay? Here, it's just a 1. So it will go as high as 1 and as -1 coming down. Then the period, we said, is 2 pi over b. Now 2 pi over b, in this case, it is the number that is attached to x. You know that the number that is attached to x, it is just because x over 2 is just the same as 1 over 2 that was multiplied by x, right? It's just the same thing. So the number that is attached to x is a half. So in this case, we're dividing that by a half. And when you divide by a half, you know that you're going to be dividing. So you're going to have 2 pi multiplied by 2. And 2 pi multiplied by 2, that is just a 4 pi. That's where our graph is going to end. Then our vertical shift, okay, it will show where our graph is going to be starting from. Okay, so what are we going to have? Our vertical shift, in this case, it hasn't shifted anywhere, so it is just 0. So these are marks, okay? These are marks. Everything that we're writing, these are the marks. So let's say this is our graph, y-axis, x-axis, okay? Now what do we now do? We're saying it to be alternating between 1 and -1. Then it is ending at 4 pi. That is the period, the number of cycles is going to take. Now we have to again demarcate it into 4 areas. The half of 4 pi, that is just a 2 pi. The half of 2 pi, or between 0 and 2 pi, it will just be pi. Then between 2 pi and 4 pi, it will just be 3 pi. Or you get the same pi and you multiply it by 3. Okay, so this is what we have. So if you look at the value of the graph itself, it is positive. Because it is positive, it's going to be going up. Therefore, where is our graph going to pass through? It's going to pass at 2 pi and at 4 pi. So it's going to go up and come down like that. So how is our graph going to look like? It's going to move like that. So this is a graph and you are done. Let's solve another one. The other one is y is equals to cos 3x. Okay, so y is equals to cos 3x. So it's the same drill: amplitude, period, vertical shift. The amplitude, how high? Okay, you're able to see that the coefficient of the function itself is just a 1, so the amplitude is a 1. The period, it is 2 pi over the coefficient of x. The coefficient of x in this case, it is 3, so it is 2 pi over 3. The vertical shift is just a 0. It hasn't shifted in any direction. We have everything that we need to graph this function. So this is the y-axis, this is the x-axis. Okay, then what do we now have? We are saying the amplitude is 1, so to be alternating between 1 and -1. Then we're saying this graph is going to end at 2 pi over 3. Okay, now we have to find the half of 2 pi over 3. If I multiply this by half, you're able to see that I'm just going to have 2 pi over 6. Okay, so that's what I'm going to put on the middle here. So this will be pi over 6. Then between 0, this is the graph of cos. Okay, so between 0 and what's this, 2 pi over that. Then between the half of pi over 6, what is it going to be? What did I do? This multiplied by half is 2 pi over 6. This will give us 2 pi over 6. 2 pi over 6 is just the same as 1 pi, or let me say pi over 3. Okay, so pardon me for that. So this will be pi over, pi over 3. Then when I found now the half of this is going to give me pi over 6. When I find pi over 6, when I multiply by 3, I'm going to have what am I going to have? I'm going to have pi over 2. Okay, now that I've got this, I've got everything that I have or that I need for to graph this function. Now you know that the cos function, it always starts at the top and it's going to end at the other top. Okay, that's the cos. So it means it's going to pass through this point, come at this point and pass through that point. So it's going to move like that. Okay, I've missed that point, but that's how you graph this one. Okay, so you have to pass through that point. So this is how you are going to solve this question. Okay, let's solve another one. We've got y is equals to cos, is it pi over x over 3? Okay, this is very interesting. So we are saying e is y is equals to negative sine, then we've got pi x over 2. Okay, so what do we do? Let's find the amplitude, the period, and the vertical shift. The amplitude in this case, you're able to see that it is a negative 1. Now it's a negative 1. Now you have to find the absolute value. The amplitude is always the absolute value. Okay, so in this case the absolute value of 1 would just be a 1. Okay, so that's going to be alternating between 1 and negative 1. Then if we're going to find the period, we're going to say 2 pi over b. In this case b is a number that is attached to letter x. Now you're able to see that what is attached to x, it is pi over 2. So I'm going to put pi over 2. It means we're dividing 2 pi divided by pi over 2. So what am I going to have? I'm going to have 2 pi multiplied by 2 over pi. The pi and the pi are going to cancel. Therefore, I just have 2 multiplied by 2, which will just give me a 4. Therefore, our period is a 4. Our period is a 4. Our vertical shift, it hasn't shifted anywhere. So this is just a 0. So now how do we now graph? We have everything that we need to graph this expression. So now what do we do? So we're ending at 4. So the period is 4. The half of 4 is just a 2. The half of 2 is a 1. Between 2 and 4, that is a 3. So now that we've got this, our amplitude is 1, so it will be alternating between 1 and negative 1. Okay, then this is a negative. Okay, it is negative. If you look at the function, it is negative. So because it is negative, what are we going to do? Okay, so that is very, very important for you to know. So instead of it starting at it will start here, but now it's going to pass through this point and it's going to pass at the last point. But now you know that the sine function goes up, right? But because it's negative, it's going to come down, pass through this point, and also go down and go back to where to rest. So this is going to go like that, go like this, and like that, and you pass through this point. So this is going to be your graph. Okay, so this is very important for you to know. Now let's solve another one which maybe has a vertical shift. Let's solve well, just from solving e, let's solve f. F is equals to y is equals to 1 plus cos 2x 2 pi x. Okay, good. So we are saying f is equals to y is equals to negative 1 plus cos 2 pi x. Okay, so how do we solve such a one? So we are also going to do the same. We're going to find the amplitude. The amplitude, it is the number that is attached in front of the fraction. Now you're able to see that in front of the fraction is just a positive number, right? So this will just be a 1, okay? Then we come to the period. The period, it's 2 pi over b. In this case, b is the coefficient that is attached to x. The coefficient that is attached to x, you're able to see that is 2x, right? So you're going to put it. So 2x or 2 pi. So 2 pi divided by 2 pi, that will just be 1. Our period will be 1. Our vertical shift, you're able to see that they've given us a vertical shift of negative 1. Okay? So they've given us a vertical shift of 1. So the entire graph is going to shift upward by 1. Okay? So what are we now going to do? So the vertical shift, you're able to see that it is 1. So let's now graph. So this is our graph. So this is our VS. So we're saying the amplitude is between 1 and 1. Now, because the graph has been shifted, the amplitude was at 1, okay? Now that the graph has been shifted by 1 unit, so it means where is our graph going to be alternating at? So instead of having a 1, it has been shifted to go as high as 2, okay? So it's just going to be alternating between that. So what you are going to do is that to the amplitude add a 1 and to the amplitude subtract a 1. When you add a 1, it shows you how high the graph is going to go. When you subtract by 1, it shows you how low your graph is going to be. So now if we add 1 to 1, that is just a 2. If we subtract the 2, we're just going to get a 0. So that's where the graph is going to be alternating, you know, in terms of alternation. Now the period we're saying it is 1. So this graph is going to move until it reaches to 1. Now the half of 1, it is 0.5. Okay, let me write it as 0.5. Then the half of 0.5, what are you going to have? Okay, and between 1 and 0.5, and there are all those kind of things. So this is a cosine graph. Look at now, it is a positive function, so it's going to go in the positive, and you know that the cosine graph moves from this point and it reaches at that point. Okay, so it's going to move, passes through this point, so to move like that, passes through this point, and it goes like that. So this will be our graph of that. So this is how we solve this question. So let's solve the last question. Given that the range of the sine and cos and tan are that and respective, evaluate the following given the answers in radians. So we are finding A is sine inverse of the square root of 3 over 2. Okay, we've been given the range of those values. Negative pi over 2, which is just negative 90 to 180, and 0 to 180, and those. Okay, even beta. So what do we now do for this one? Okay, so sine inverse of the root of that. So what are we going to have? So what this means is that x itself was equals to the square root of 2, sine x was equals to the square root of 3 over 2. That was the initial, so it means x is equals to that. Okay, so now that we know what this is, so what is the square root of 3 over 2 when it comes to special angles? The square root of 3 over 2, what is that? What this is like one of Okay, what is that? Yes, so that is like 60. So this is 60. Okay, this is sine 60. So that would be, there's nothing like solving here. Once you just find this, you are good. So sine 60. Okay, so that would be the answer, sine 60 degrees. Or because I've also seen some pi's here in terms of radians, so this is just the same as pi over 3. Okay, now when you go to B, we are finding tan inverse of the square root of 3. Initially, how was it? That's the question that you should ask yourself. Initially, how was it? It means that this one was just the tan, tan, let me say tan theta or tan x was just equals to negative 3. Okay, now negative 3, what special angle is it? Or just the square root of 3? The square root of 3, what special angle is it? Okay, so it's just the same as 60. Okay, so this is tan 60. Now there's a negative, so I also put a negative. If you are going to write it in radians, okay, this is just the same as pi over 3 as well. So very simple and very straightforward. So even the other ones, that's how we're going to do them. Now let's solve now the last question. This is the very last question in your tutorial sheet. Given that the range of the function sine that and that is respectively, evaluate the following. So this is just the same as the previous one, just from solving sine cos inverse of 1 over 2. Solve what is in the bracket. So initially, how was it? It was something like cos, let's say x is equals to 1 over 2. What is 1 over 2? Okay, x will be equals to 1 over 2. What is 1 over 2 when it comes to special angles? 1 over 2 is just the same as 60. Okay, when you're relating it to cos. Okay, so you're just finding sine. What is in the bracket is just the same as 60. Now what is sine 60? That's the question that you should do ask yourself. So you would have found the answer. Sine 60 in terms of special angles, you know that this is just the same as root 3 over 2. If you want to write it like that, and you are done. And the last question is the same. That's how you're going to do them. So everything that we've discussed about in this tutorial sheet, they are there on the drive. Okay, so you are going to, if you're going to be stuck on any part, graphing, solving equations, proving identities, everything is there. So this is why we end from today. See you next time.